All right, everyone, please join me in welcoming Mallika Iyer. She's a cloud platform specialist with Pivotal, and she's going to be talking about some of the lessons learned she has gleaned from working with large-scale technology with big companies. So please join me in welcoming Mallika.
So good morning, everyone. Cloud anti-patterns, that's what I'm going to talk about. So there's an interesting story behind the presentation. So I work a lot with large enterprise customers as they start down the journey of building cloud-native applications. And some of the things that they do, it makes me just exclaim, and why exactly are they doing this? And usually, after a particularly interesting meeting, I end up talking to my husband, or more like ranting to him and saying, I can't believe he did that. I can't believe they were planning to do that. And it got to a point where he said, you should actually go talk about this to people who will benefit from this and stop talking to me about this. So that's how the idea for the talk came together. And what I've done is I have distilled everything that I have seen as bad practices or anti-patterns into a collection of short anecdotes. So a little bit about who I am. I work at Pivotal as a Cloud Foundry specialist. You can follow me on social media up there. My Twitter handle is up there. Stalk me on LinkedIn. My background is a blend of application development and NoSQL technology, way before NoSQL technology was even cool. So I worked at UBS. I currently work at Pivotal. I worked extensively at MarkLogic and Splunk, and currently, I focus all my energy on Cloud Foundry, building Internet of Things applications with customers, kind of guiding them on this cloud-native journey. So when I'm not doing that, this is what I do. I'm a certified TRX trainer. I'm a huge fitness junkie, and I spend a lot of time with my 2 German Shepherds. So, anyone here a Simpsons fan? So I'm a huge Simpsons fan, and I remember this episode, and it really resonated with me when I talk to customers and they say, hey, this is not working, or hey, maybe we made a mistake kind of going down this path. And I realize it's the tendency to blame something that you don't really understand. It's very easy to shoot the messenger when what you're really doing is kind of an anti-pattern. You shouldn't have done it this way in the first place. So these are all the anti-patterns I'm going to focus on. But before we even begin, depending on who you ask, you're going to get a different definition. For example, when you talk about microservices, what exactly does microservices really mean? So I like to set the stage and so that everybody is on the same page. I'm a huge fan of definitions. So what is it really? It is a software architecture design pattern. It's not a software, it's a design pattern where you're breaking up a huge complex application or you're architecting a net new application as a suite of smaller, individual, loosely coupled, highly autonomous, highly independent processes. Ideally, they're using language agnostic APIs to communicate with each other, and they work on doing one task alone. So it's very similar if you think about if you do object-oriented programming the right way, then the way you're architecting an object-oriented programming, kind of take that up a couple of levels, and you're architecting an application in this manner. So containers, I'm sure everybody here is familiar with containers. So depending on, again, who you ask, they have a different definition of it. So what is a container really? So the most common ones, they're Docker, Warden, Garden. So it's an isolated, a lightweight environment, and it is allowing you to run your application or run your service or run your microservice without relying on a separate underlying operating system. So continuous integration. Again, this is a term we hear a lot, and some people use it really well, and some people kind of use it poorly and make an automation nightmare for them. So ideally, what is continuous integration? You're merging all of your developer working copies to a shared main line. You're doing this several times a day. You're ideally doing it in an automatic way. And finally, continuous delivery. So what exactly do you mean by this term? It's an approach where you have multiple teams, they're working separately, they're producing software in short cycles, and they're releasing software autonomously, they're releasing software reliably, predictably, and this is the thing that allows you to make sure, if used efficiently, that a release is no longer a major event where you have people on alert at night saying, hey, something might break, you're gonna have to wake up and fix this. So let's go into the first anti-pattern. So the first one, I like to call it finding the sweet spot. So if you really think about microservices in containers, that's really a function of development. Developers write these microservices. And when you think about continuous delivery, it's a function of the ops team. They are tasked with setting it up properly so that the application or the microservice in question is actually getting deployed to the environment reliably. And continuous integration, it's usually a function of development, and it's a function of operations. So a lot of times what I see is when customers come to us and they say, hey, we need to get more agile, or hey, we need to start down this path of building cloud-native applications, they usually start at automation. Automation in some shape or form. It might be really just as simple as, hey, we really need to start thinking about using vRealize or Chef or Puppet or Ansible or SaltStack. Or it could be a little bit further beyond that. So what ends up happening is when you look at these three parts separately, you can end up selecting multiple technologies and essentially create silos of technologies for yourself, because unless and until globally in an organization you're using the same thing, your ops team now has to support all the different choices of technology for each of these buckets. So where these three pieces meet is where I see something like a cloud-native platform. So a cloud-native platform, something like Cloud Foundry, it allows you to manage containers without actually having to think about it. All you're thinking about is you're focusing on deploying the actual microservice itself. It allows you to integrate with continuous integration and continuous delivery software so that, again, all you're thinking about is actually writing the code. This is usually the reaction that I get initially. Nobody wants to acknowledge this because, hey, we should really be starting at the very, very basic component. We have to automate something. Only then we can actually go down this path. That's not necessary, because what's going to happen is you're going to have to redo things, and you're going to waste several cycles doing that. So I highly recommend that if you're starting down the path of building cloud-native applications and you're starting down the path of automating your development and deployment cycles, look at something that has the components of all these three different areas: microservices, continuous integration, and continuous delivery. Where do they all meet, and where do they all come together so that you don't have to do a lot of the work again and again, and you also don't have to manage multiple different kinds of technologies? So the next one is a common conundrum whenever I'm talking to on the development side of the house in any organization versus when I'm talking to the ops side of any organization. So usually the problem is companies want to innovate. They absolutely want to release cool features to production yesterday or now, whatever is sooner. And then they run into the DevOps side or the ops side of the house, because ops side has to also actually manage things like, hey, the application needs to actually be up. It has to actually scale. It has to actually, they have to think about high availability. They have to think about uptime. They have to think about outliers, edge cases. What if you have a tremendous surge or uptick in traffic? How do you handle all of that? Developers don't really care necessarily about that. They want to, but they want to just release cool things. So what ends up happening is there is no collaboration because there is no software or there is no platform potentially that they can meet on. Everybody's unhappy, business is angry, and most often, very common, everybody likes to blame the IT ops side of the house, which is really, really unfair because the ops side is why the applications are up to begin with. So this is kind of the situation that I've actually been dealing with one of our customers where developers really want to release cool new features, and the ops side just cuts them off, saying, no, you broke the build the last time, so we're not going to do this until we kind of make sure that nothing is ever going to break, ever. So is there some kind of a midway that we can take, a middle ground? You don't really have to choose if you select the right platform. And the reason I am talking about Cloud Foundry is an open source platform. Pivotal has an enterprise version of Cloud Foundry, but that's not the reason why I'm talking about this. This particular feature of Cloud Foundry is really, really cool. It is something like Inception almost. It heals itself. It heals itself on various levels. So the first layer that it heals itself on is it allows you to distribute any application that you're deploying to Cloud Foundry, something that Casey showed you earlier today. It allows you to distribute that across multiple availability zones so that if one instance of your app is down, that doesn't mean that there is an interruption in service. The next level is, let's say your app instances go down. Cloud Foundry has a mechanism to monitor itself so that if something goes down, it'll automatically try and redeploy that application, while it can also obviously say, hey, something went down, I tried to recreate it just so that you know. But it's going to try to do that itself. The other cool thing is it can monitor itself. So the Cloud Foundry is comprised of different components. It monitors itself, it resurrects itself, and it also goes a level further because Cloud Foundry is a PaaS. It runs on an infrastructure as a service. So it goes a layer beyond that, and it can communicate with the infrastructure as a service in question and actually resurrect entire VMs if one of the VMs goes down. And this is the other cool thing about Cloud Foundry is that it is comprised of two separate parts. There is the operations piece of it, the part that the DevOps or the ops admin is going to be dealing with, monitoring the entire deployment. And then there is the application management part of it, where you're actually exposing the environment to developers. They are actually pushing applications out, tying it to multiple data services, literally with a one-click deployment. What happens if half of Cloud Foundry just gets blown away? What if the entire operations manager dies? Nothing is going to happen to the rest of your applications because there is no dependency between these two beyond the initial, anytime you want to install something, anytime you want to update something, you're going to have to deal with the operations side of it. So it's inherently highly available in that no matter how hard you try, until and unless you manually go in and kill every single application instance as well as Cloud Foundry itself, you're guaranteed continuous uptime, almost. So what that allows you to do is use something that's inherently highly available and also give you a complete visibility into everything that any developer is doing with the environment. I mean, there are several instances where I have seen that developers request, a VM, or they request a sandbox because they want to test something out. And when they actually get it, maybe millions of years later, ops has no visibility into what the hell they're doing with that environment. It could just be sitting there, and it's basically a waste of resources that could otherwise be allocated to something else. So this is one of my favorites. It's a paradox. I mean, the gentleman up here right before me was talking about containers. So this kind of elaborates on that path a little bit. So the monolithic microservice is a shocking pattern that I see customers try to explore. So the temptation here is you want to group multiple microservices that might be very similar in functionality. You want to group them in the same container. So I was actually talking to the enterprise architect in one of the large Fortune 500 companies a while back. And I mean, at Pivotal, we use Google Hangouts for everything. So when you're actually in a meeting, you know if you know what exactly people are doing. You can see what they're doing. You can see if they're eating. You can see if they're yawning. But this was on a conference call, so I couldn't actually see what exactly he was thinking or doing when he asked me these questions. So he started going down the path of, so how should I deploy, how many microservices should I deploy per container? Can I deploy more than one? And then he kind of started digging down that path. And I'm thinking to myself, no, that violates the core concept. I mean, why would you want to deploy more than one microservice per container? The temptation is that you're thinking, okay, they're all similar, they all need to communicate with each other, maybe it just makes sense to group them together. But what you're actually doing is you're creating a monolithic pocket in an architecture that is supposed to be inherently cloud native, inherently supposed to follow the microservice paradigm. So what's going to happen, as it always does, is all those microservices eventually are going to have to change because you introduce something to them. And then what ends up happening is anytime you change one thing in that one container where you have decided to push in 5 microservices, you're going to have to test every single other microservice that you decided to bundle in that same container. And now you're going to have a problem of you can't really scale it up very quickly. You can't really deploy the changes as fast as you can or as fast as you could if you had ideally not given into the temptation of one microservice, more than one microservice per container. So essentially, you're creating a large monolithical microservices app. I don't even know what that is. But basically, you are screwing yourself over. So don't do this. So the next one is, anybody here familiar or heard the term code smells? This is basically the equivalent of that, but in the microservices world. So what exactly is a microservice smell, or what is the equivalent of microservice smell? So I had this customer who was all in on the cloud native path, and they said, okay, let's actually start breaking down everything. So the temptation is, if you prematurely decide to decompose your microservices, what can happen is, let's give you a hypothetical. I've changed the names to, for confidentiality, but this was the actual situation where, let's say this company who creates amazing stuff, they have this product that was working really, really well, still does, called Awesome. So they did a lot of market research, they did sophisticated data analytics, and they decided that there is actually a space in the market for another niche product offering called Super Awesome. And since they were going down the cloud native path, and they were actually going to build everything as a suite of microservices, and these products were somewhat similar. So they said, hey, why not give ourselves a break and cut to the chase and actually leverage some of the microservices from the first product that actually works really well and has been tested into the second one. So now they started consuming these common subset of microservices across both. And as their market research showed, the other product basically took on a life of its own. It became really popular, and then they had to add a lot of other features to the other product, and then they had to at that point they realized they can't really leverage the same common set of microservices across both these applications, and they basically had to rewrite everything for the new application. So what this initially creates is, it's basically don't really be in a hurry to go the microservices path. Let it be very, very gradual, and decide if you want to not repeat yourself at the cost of actually having to redo everything a little bit later. So I call these APIs, service registry, and discovery and fault tolerance. I call them the 3 musketeers of building cloud native applications. So here's why. Let's say that you actually started down this path of building applications and you have multiple microservices. The problem with a microservices-oriented architecture is they're all useless if they can't talk to each other. So let's say you have 100 or so microservices. They all need to talk to each other so that they can communicate. And a lot of these, ideally, if they're all being developed by multiple teams, autonomously, loosely coupled, the way it should be, they're all changing simultaneously. They're all getting deployed simultaneously because they're not supposed to be dependent on each other. And let's say you really, really went all in and said, I'm going to use the right tool for each microservice. So now you have a bunch of, you have an application comprised in maybe 5 or so different languages. So what is an elegant solution for this? All these microservices need to talk to each other. So ideal way to do this is to use or create a language-independent API. Swagger is one of my favorites. It allows you to do interactive documentation. It allows you to honor the contract between the different services that are talking to each other. And it also interactively documents everything so that any change you did to one microservice is broadcasted and exposed to everything else. So the next one is service discovery and registry. So, okay, you have 100 or so microservices. They're all talking to each other. Now what? Every time a new microservice enters that fold, all the other microservices either have to be manually informed that, hey, there is this new kid on the block, or you're going to have to use something like Eureka, or basically a service registry and discovery tool. Eureka is something that's based on Netflix's work, and what we did in Cloud Foundry is we adopted that into what is called today as Spring Cloud Services. So this would be crucial because it allows you to automate service registry and service discovery, because as your application grows, you're going to suddenly find yourself dealing with hundreds of microservices, and it starts to really, really become a problem at scale. So the last one is fault tolerance. So now you have a bunch of internal services that are feeding your application. Let's say that there is a failure somewhere there. They fail for some reason, and usual case, what happens is the failure propagates to the API layer, and what ends up happening is you could have an interruption in service. So something like this actually happened, I believe, with Best Buy last year or year before that, where during a peak shopping season, their application just crashed, and nobody could actually go and buy anything. I think it was during Black Friday, if I remember right. And now what's happening is you're going to lose several millions of dollars just because your application went down at the wrong time and you couldn't isolate the error quickly enough. So an elegant way to handle this up front is anticipate that this could happen and use something like a circuit breaker. So Hystrix is another cool technology that, again, came out of Netflix, and it's also part of Spring Cloud Services. But what it allows you to do is it allows you to figure out, okay, I might have an interruption in service at this point in my suite of services. Let's isolate that, let's watch that, and if something starts malfunctioning, let's break the connection from that microservice to the rest of the application so that now nothing goes down and you have a fallback plan, basically a graceful degradation, while your developers and your ops team is actually working on figuring that problem out. The beauty of this is, in this situation, you have been expecting that something might go wrong and you're actually watching your application. So this is, again, boil tea, not the ocean. It's the most common problem that I come across. It's basically, how do you actually move an application over to a cloud-native path? The temptation is, should I just lift and shift the entire monolithic application? But that's a bad idea. I mean, if something's working fine, don't break it. The temptation is, again, trying to rewrite the entire application too quickly. So again, that's basically trying to do too much, too fast, and too soon. So the main challenges here is it's unrealistic. It's never going to happen because this is going to be discussed on PowerPoint to death at multiple companies and multiple teams, and it's basically going to live on PowerPoint for the rest of its life. So I'm sure many of you have some experience or some exposure to ideas, really good ideas that just died on PowerPoint. So how do you kind of go about this? So figure out, and this is what one of our customers did recently, figure out a function that can be rebuilt. It has to be small enough, but it has to be powerful enough that it would actually benefit from being rewritten. It would actually help the application. It would actually benefit innovation in your application. It might be something that requires optimization. It might be something that's always impacting all the other parts of your application whenever you add a new feature or you add a change. So, and this is something that's actually, it's usually not on top of mind of many people, write something new. Whenever there's a new feature that has to be added to an existing monolith, start creating a clear layer of separation between the existing monolithic application and all the new features that you're going to be developing as in the microservices pattern. So what it allows you to do is it allows you to minimize the impact on the rest of your application that's already working, allows you to go about this in a very, very gradual way. And then it also, as you start writing the new applications or you start re-architecting portions of the old application, the technical debt associated with the rest of it is going to come to the surface. You're going to be able to consume it piecemeal as opposed to kind of just be a Python and kind of swallow the whole thing and then basically explode. So basically, start really, really small, and this is really not intuitive. Start really, really new. So this is something I actually saw on Twitter the other day, where someone had tweeted about they replaced their monolith with microservices, so every outage could be more like a murder mystery. So I'm not sure how many of you have encountered this, but this is the reality, right? Essentially, when you're architecting an application, you're following this pattern, you are creating a large distributed application. So it becomes harder and harder to isolate where an error originated. And it becomes even harder if you have multiple teams working on it, and everybody's like, no, I tested mine, it's working fine, there's some problem in yours. So how do you kind of avoid this? So the problem is, in a distributed application, how do you try to isolate and figure out where you should start to look? And the solution is 3 things. Logging is your best friend. I already heard that a couple of times today, so I'm just restating that, I guess. Dynamic tracing is your second best friend. This is really, really useful when you are trying to figure out if there isn't an actual error, but maybe there is a timeout. So as the request is going from microservice to microservice, you're able to figure out, if you use something like Zipkin, if you're able to actually figure out where there is, where maybe a microservice is taking too long to respond, where maybe it's timing out. So you can isolate and start to figure out where to look, something that might not be evident when an individual team is testing their work. And the last one is application performance monitoring tools. So with every application, with every microservice, use something like New Relic or DripStat or any other tool that you prefer to do APM, because that exposes, again, a lot of logs in a very nice, easy to consume way, and you're not basically spending days and weeks looking at log files trying to figure out what the hell is going on. So I don't think I need to elaborate too much on this, but basically, build pipelines are going to be your best friends when you start to automate everything. And they could also be your worst enemies if you automate the wrong thing, because now what you're doing is automating errors at scale. So I've seen this happen, and what is the goal here? The goal is, ideally, you want to deliver tested, mature software at every iteration. So it's going from dev to test to QA. Each time you're making the code stronger and more mature, so that at some point it's just running like a very, very smooth, well-oiled machine. And the way I see the DevOps part function over here is, ops is really the part that actually holds everything together. They're the folks that are actually working behind the scenes, automating every part of this, so that this is actually able to run very smoothly. So you're actually able to focus on adding new features, building great software, and not worrying about, okay, it went from dev to test, all these errors, push it back. So if you're able to automate testing along with your build, if you're able to automate that with every single deployment to every environment, it's going to be really, really useful. And the last thing is, and I'm coming up at my time, so the last thing here is siloed search. So this is, I personally find this very interesting because what exactly does search really have to do when you're building cloud native applications? So this is something that a very, very large global organization faced where they were using Solr. They were probably one of the largest enterprise users of Solr. And they also had a lot of microservices communicating back and forth across the different applications, across the different teams. And their main problem was that their search data was stale, and users were unable to perform unified search across all of the different data silos because what was happening was every time their microservice would publish something new, their Solr index would not update quickly enough. So one thing that they did was they basically created an enterprise-wide data bus. What this did, they used RabbitMQ, but you could use Kafka or something similar. But what this did was it was basically listening in on all the activity that every single microservice was publishing or doing. So what they could also do is, what they ended up doing is what you could do is multiple microservices are asynchronously just publishing out very interesting data points to this enterprise-wide database. So in this case, it was RabbitMQ. And now you have their Solr, in this situation it was Solr, but basically you have your search event listeners who are continuously listening to that enterprise-wide data bus, and then they're updating their search indices in real time so that now you never have to deal with the situation of stale data when you are using this kind of an architecture. And this starts to become really, really important when search is a very big part of your offering or of your core application. So what they ended up doing was really, instead of doing something like a data push model, they were going to a very real-time data pull model. So just to summarize really quickly everything that we talked about, so don't ignore the sweet spot. If you can find a platform or a tool set that does more than one thing for you, take a second look at that because it's going to be able to remove some of the work for you. Again, you don't really have to always choose between risk mitigation and innovation. Again, look deeper into something like Cloud Foundry or a platform that can actually guarantee a certain degree of uptime. Don't contradict yourself. Basically, don't do the monolithic microservice because it's just you're creating more problems for yourself. Again, be wary of microservice smells. So know when to repeat yourself and know when to not repeat yourselves. We talked about the three Musketeers: APIs, service registries, discovery, fault tolerance, using circuit breakers, and then finally start small, start new, and you don't really need to treat a microservice architecture like a murder mystery. So logging, APM, dynamic tracing, these are all going to be your best friends and going to make life a lot easier for you. And lastly, automation is your friend, but don't automate the wrong thing because then you're going to end up automating things at scale. Basically, you're automating errors at scale. Don't do that. And the last one is siloed search. Anytime you're using search at scale, it's going to ruin your customer experience if you don't address that along with building cloud native applications. So it really should never be an afterthought. You should start thinking of it up front as you're architecting your application. So that's all I had. And I think I'm just up. So questions, comments?
Big hand for Mallika. Please